This is chapter 9, part 2. So we did learn about some part of the linear momentums and collision already. This is like the later part. We will have some relation of the system of the particle, not only the single particle now. We will look them as a system. They may have more than one of the particle, and we can identify where's their center of mass, and that can represent the center point like of the whole particle in the system. So we will start from this part now. So I will start from the center of mass section. So how we quantify and identify where's the center of mass is? In fact, it's come from you hang one things like a object of irregular shape. In this case, is hippopotamus. The center of mass or center of weight or center of gravity is where all of the mass represent there. So that this point is represent the center of mass. What does that mean? That means all the weight go through this point. If you hang this hippopotamus like this, the weight gonna go down through the center of mass or center of gravity point. And if you hang to another axis, like you hang the hippopotamus on this plane, if this point is the center of mass or center of gravity, the weight of the mass that represents this hippopotamus gonna go through this point. We will have some definition on this if we know like a y position from the axis. We will know x position to the axis, and with x0, y0 coordinate, we call this as your cm, the center of mass in terms of coordinate. We will ignore the definition of torque from now since we haven't learned about the torque yet. But the torque is the force, in this case, the gravitational force multiplied with the length that perpendicular to the force, which is in this case, if you hang the hippopotamus like this distance is x0. If you hang the hippo like this, the distance here is y0. And when you combine this knowledge, you can find xcm and ycm. In this case, I can't find my arrows. Sorry. Sorry. This is, I will rewrite it. xcm and ycm as the distance that you observe here is x0, y0. Okay, I will go back first. I know I will rush this part first. No worry. This now I'm trying to summarize. If you would like to determine the central mass in 3 dimensions, now in 3D, how can you find all the xcm, ycm, and zcm? The definition is what you try to work out on the mass and the distance. So you have the summation of the mass of the system of particle. For example, in this case, you have mass laid down along x-axis, not in y-axis, because in y-axis all this mass also at y equal to 0 position. So what is happened here? If you have this system with the 2 mass, you have to find the individual mass multiplied with the distance from the axis. For example, sigma mi xi here, you can find it like sigma mi xi equal to sigma m1 x1 plus m2 x2. Since this system have 2 particles, right? And what is m1? M1 is this part. x1 is this distance from the axis. How about the m2? M2 is this mass, and this is x2 is the distance. So you multiply mi xi and summation like this. In order to find the XCM, now you have to find the average. So you divide with the total mass, which is M1 plus M2. The big M here is the total mass that you have in the system. So M is the sigma Mi. So now you sum up, because you divide this part with big M. So this is your XCM. So the XCM is this position. So we can use this type of formula to extract the XCM, YCM, and ZCM to determine the center of mass in terms of coordinate. Since we learned about the vectors already, we know that another kind of vector that we use for represent the position of the particle. If the particle lay down over here and you have X, Y, and Z axis, you can use the positional vector to represent the position. This is the source of the positional vectors. If you would like to identify this position as the positional vector of the center of mass. So what you have to do, you know XCM, so you have XCM with I. So it's point out in I direction, which is X direction, plus YCM that you have from the coordinate and put J hatch to represent is point out in a Y direction with this magnitude, and ZCM with K hatch. So now you have the vectors of RCM already. So you sum up all individual with the vectors, or each component is depend your preference. You can choose whether you would like to find the XCM in terms of coordinate or positional vector. Let's go to the first problem. This is example 9.10. You have the system of 3 particles now. I will explain later like why we have to know about the center of mass of the system of the particle. Because in terms of doing calculation, like in the kinematics, like 4 measure kinematic equation, you can sub all the information that you know and use mass of the center of mass or the position of the center of mass as your represent of this whole system. So from now, we would like to determine this RCM. So what is RCM here? Or you can just find out XCM, YCM, ZCM. Any of these is fine now, because we would like to find the center of mass of the system. So in order to find XCM, YCM, or ZCM, you have to find the relation, right? The equation that we have. The XCM come from sigma MIXI over the sigma MI, or the total mass. So in this case, mass M1 equal to M2 and M3 is 2 kilograms. So big M or sigma M, like M1 plus M2 plus M3 now, they are 1, 2, 3, 4 kilograms. Now you know big M is 4 kilograms. The individual, you can have it. So to find the XCM, now you can just sub all the information you know in already. So it can be M1 X1 plus M2 X2 plus M3 X3 and divide by big M or total M. Right. Sub M1 in is 1 kilogram. X1 is this position. You can see it's 1 meter. Plus M2 is 1 kilogram. X2, as you can read out from this chart, this is original position, so it's 2 meter. And how about M3? M3 is over here. There's no position on X direction, so X3 is 0 in this case. But you have to divide by total M for the total mass system, so divide by 4. By this, you can find the XCM now. XCM equal to XCM equal to 3/4 or 0.75 meter. So to find YCM, now in this case you don't have any ZCM, right? Because we look only into dimension. This is 2D system. So YCM is also come from the same relation. Sorry that I'm not changing the color of the pens because I don't know why some problem with this pen. I cannot change color or using any eraser now. So I'll try to do my best on this. So this is M1Y1 plus M2Y2 plus M3Y3 over the big M. Now if you look at y-axis here, M1, M2 dash no position along y-axis, only M3, right? So all of M1, M2 going to be zeros because y1 and y2 is zeros. So now you have only M3. So it's 2 multiplied with the distance, which is 2 meter over 4. So it's equal to 1 meter. So now you can have the center of mass of this system, 3 particles. So it's equal to XCM and YCM. So that is 0.75 and 1 meter. If you would write down as a vectors, so your RCM is 0.75 I plus 1J in unit of meter. This is the answer for this case. You can see this is how, using the understanding of just the definition of the center of mass to determine any particle system that you have here, and you can recognize this position as the center of mass to represent the whole system.